This is going to be an archaeological tour into computers at Utah and before and after. This is really ancient history, and so when I show you some images, I really would like you not to laugh. Okay, because at the time, and I'll explain that, these images were a little harder to make than they looked. So first I'm going to tell you about ARPA. And for those of you who believe that government doesn't know how to fund research, I always point to the example of ARPA, because ARPA is probably the best example of the best research funding that the government has done. ARPA was founded in 1958 under the Eisenhower administration in response to Sputnik. The Russians put up a suborbital satellite, and that really got Kennedy's attention. And so ARPA was founded by Robert McNamara under the Kennedy administration. Oh, excuse me, IPTO was, the Information Processing Technology Office was founded by Robert McNamara. Now, IPTO was focused primarily on computer research, on what you could do with computers and how they were going to develop. And in 1962, that was not much. I mean, they were starting to be used fairly universally, but they are not anything like the world we live in today. The head of IPTO was a visionary named J.C.R. Licklider, and he decided that the best way to do research was to pick superlative institutions, focus on core subject matter in those institutions, and fund them heavily. It was very, very, very different philosophy than the National Science Foundation, where you pick a single researcher, you give them a little money, and you hope something comes out of it. So what ARPA did is they funded about a dozen universities across the United States, and they were called Centers of Excellence. And what happened in history because of that, you'll see. In 1965, Ivan Sutherland, who also was a graphics person who ended up at Utah, was the head of IPTO, and he funded David Evans at the University of Utah to start computer science department here and to fund the ARPA project at the University of Utah. Dave Evans in '66 moved to Utah to head the computer science department. Now, how many people were in the computer science department at that time? There were two. There was Dave Evans and the ex-head of the computer science department who stayed on as a professor. His name, I can't even remember his name. So, Ivan Sutherland then in '67 gave up his head of IPTO and moved to Utah. In 1967, the helm of IPTO was handed over to a fellow named Bob Taylor. Now remember that name because that's an important name. In 1970, Bob Taylor moved to Utah. Okay, so I was a student at Utah at the at the transition of the computer science department from the old head to David Evans. And so I was in the computer science department essentially from about 1965 through 1969. And the idea is to study man-machine interaction. And so the charter of the Utah group was to study man-machine interaction and how you in particular could use graphics to help people solve problems. Well, the Centers of Excellence of ARPA were at Stanford University, Berkeley, Stanford Research Institute, UCLA, RAND Corporation, Systems Development Corporation, University of Illinois, Washington University at St. Louis, Carnegie Mellon, Bell Labs, Bolt, Brannick and Newman, and MIT, and Harvard. So they all had very different charters. So University of Illinois dealt with supercomputers. If you've all ever heard of the ILLIAC 4, that's where that was done. Washington University was Wes Clark, who built modular computers. UC Berkeley did time sharing. Stanford University, John McCarthy just recently died. He did the Stanford research in artificial intelligence at Stanford. RAND Corporation did computer networking. System Development Corp did computer networking. So a whole bunch of centers of excellence. And they were funded fairly heavily for that time. To tell you how long ago this is, that's me. That's 43 years ago. Okay, so now, because this is really an archaeological discussion, we're really going back into deep history. And I can talk about this freely because no one else is old enough to remember. Okay, so I one day thought of a way to take a geometric representation of objects and pretend as though you were viewing them and remove the hidden surfaces. And that was called the hidden surface problem. In 1968, I came up with an idea of how to do that. And this is one of the very, very first pictures. So that looks like a fairly simple thing. Let me tell you how this is made. First of all, you see it supported intersecting surfaces, and this is the first algorithm that actually did that. So we had this computer called an 1108. 1108 had a staggering 65,000 words of core memory. Okay, your iPod Nano is about 100 times faster than this machine. This was a $1.6 million machine. And you fed your deck of punch cards into it with your program, ran it through, and it would build a data structure. It would then send it to this machine, which was a PDP-8 in 1968. Okay, behind the PD-8, there were some analog output lines, and those went to a Tektronix oscilloscope. Okay, and the oscilloscope had a round screen, was this big, and it had a green phosphorus. Okay, so the idea is you ran your hidden surface algorithm, you send a data structure across the PDP-8, and it modulated lines on the screen and traced out an image, and you put a Polaroid camera in front of it, and that's actually what recorded the image. And it took, from beginning to end, about 4 minutes to make an image. And the image was 512 by 512. So this is graphics. So we never saw that previous image on a screen. Never, because there was no way to actually drive a screen in those days. So somebody say, well, television's around, why didn't you drive a television? There were no digital to analog converters fast enough or memories fast enough to drive a television. So there were no frame buffers, there were no staging areas, there was not lots of memory, there was nothing. So you ran your program and you recorded it. Now, I said, well, that's sort of boring. What if we do this? This is the very first computer-generated 3D image. And the way that you make that is when you put the Polaroid onto the front of the screen, you put a red filter, take a picture, put a blue filter, take a picture, and put a green filter and take a picture. Now you'll notice that this is green, and that's because of the green phosphorus. So this is awful. So Dave Evans said, gee, that's sort of interesting. Why don't we buy an oscilloscope with a white phosphorus on it? And he did, and we got this kind of thing. Now, the color is actually much better, but this is still a horrible picture because it looks like these donuts are sort of made out of felt. And we made dozens and dozens of pictures, and they said, yuck, the world doesn't look like this. And it occurred to me that actually if an object is shiny, there are two kinds of reflection. There's specular reflection, and there's the absorptive reflection, or the absorptive light that gives the object its color. So we made some programming changes, and we got this. Now this has life. It looks a lot better, still doing the job. So for a couple of months, sat around and said, oh, this is fun. But this is useless. This has no value to mankind because the reason it doesn't have any, there's no problem it's solving. So this is my collaborative adventure into the world. So I went over to the chemistry department and talked with one of the chemists in the chemistry department, and I said, do you have any ideas of what you would like to see? And he said, well, I have a molecule I'd like to see. And so I did some programming, and we got a molecule. And I think there were some simpler algorithms that did molecules at this time, but this one was quite nice because the bonds between the various, so green here is oxygen, blue is carbon, and the red is hydrogen. So now we could visualize molecules. That was cool. This was all done same way. Write the program, feed it in through the card reader, and come out. This one was done with Bob Smith at the geophysics department. And this was the Earth's magnetic field is sort of the surface, and then a conductivity measurement is the color. And so the correlation between height of both of these is where a mine should be. Now, in 1968, people hadn't seen images like this. These were very, very new, and this was a real application for visualizing data that you'd never seen before. Now this one I'm sort of proud of because it made the cover of Scientific American. I don't know why it doesn't fit, but it doesn't. Anyway, June 1970, there was an article about computer displays done by Ivan Sutherland, and it made it. Now, Utah, I left in 1969, but there were a whole bunch of students that were there while I was there, and they sort of moved on and did different things, and most people don't realize who they were and where they went. So there was Alan Kay, and he graduated the same year I did. He invented object-oriented programming. He worked at Xerox PARC from 1972 to 1982, headed Atari research, was an Apple fellow and then a Disney fellow. And Alan Kay's possibly one of the smartest guys I've ever met. I went to Evans and Sutherland in 1972, Xerox PARC in 1978, and co-founded with Chuck Geschke Adobe Systems in 1982. The little colored dots indicate that members of the National Academy of Engineering, Fellow of Association of the Computing Machinery, and Fellow of the American Academy of Arts and Sciences. Alan Ashton, who was actually a student of mine, co-founded WordPerfect Corporation. Jim Clark founded Silicon Graphics in 1982, founded Netscape in 1994, and founded Healtheon in 1996. Ed Catmull wanted to do full movie animation in his career, and so he went off and directed a lab at NYIT, was one of the first people to build a frame buffer so that you could actually see on the screen what was going on. VP of graphics at Lucasfilms in the early years of Lucas, and he is the founding force behind Pixar animation. So Ed is still the CEO, or I think he's still the CEO. It's now part of Disney, but he still heads Pixar Animation. Henry Fuchs took the academic route, went to the professor of computer science at University of North Carolina at Chapel Hill. Jim Blinn, everybody in the graphic world knows Jim Blinn. He's an amazing guy who figures out all kinds of algorithms. He was mostly at the Jet Propulsion Lab and then went to Microsoft. Martin Newell, everybody knows Martin Newell's teapot. He went to Xerox PARC, founded Ashlar, and then he ended up at Adobe. Jim Kajia did a lot of work. He was at Caltech and then went to Microsoft. William Newman wrote with Bob Sproul probably the first book on computer graphics. He was at Xerox PARC. Patrick Baudelaire did the first draw program. Jim Curry was a systems guy. Flagel was a graphics guy, worked with frame buffers. Anyway, notice how many people here went to Xerox PARC. There's a reason for this, and I'm going to tell you this story. So this is Xerox PARC. It's in Palo Alto, great place, sort of fits into the hillside, fairly large research institute that was founded. It was founded in 1972 by George Pake, who was a physicist. And the charter of PARC was to invent the office of the future. And what they did is they hired Bob Taylor out of Utah to form the computer sciences lab at Xerox PARC. They also hired Jerry Alkine, who came from another ARPA site back east. Bert Sutherland, Ivan's brother, who was always part of the ARPA community, formed the System Sciences Lab within PARC, and both laboratories were staffed almost exclusively from the centers of excellence around the country of ARPA. In other words, Taylor, since he was head of IPTO, knew exactly where the bodies were. So he hired the best and brightest that he could find from Berkeley, from Utah, from Harvard, from Carnegie Mellon, and that's what happened. They built, in 1973, way before the Altair and way before the Apple I and the Apple II, they built the first personal computer with a graphical user interface. And I'm going to show you that. Later, the Ethernet that we always used was invented by Bob Metcalf. Smalltalk was invented by Alan Kay. Bravo, the first text editor that you use, much like Word, was invented by Charles Simoni, and the mail client that we had was almost identical to the mail clients you had today. Now, this was in 1973. Okay, so I'm going to go to the next page. This was the Alto. Okay, it's not the teeny personal computer, but it was everyone at PARC had one of these. The screen was the size of the printed page. The reason that they could drive the screen is because they only gave 1 bit per pixel to the screen, and it was either black or white, so the data rates and the problems of converting and refreshing the screen were eliminated because you just had a black and white bitmap display. The editor worked exactly the same way that the Bravo or that the Microsoft Word editor works. There was a full set of things. We had file servers, we had laser printers. The first laser printer was built at Xerox PARC. These were all connected, the file servers and the laser printers were all connected through the Ethernet. Everybody could send mail to each other, everybody could communicate with other offices around the country, and we were connected to the internet. Well, ARPANET at that time. This was an amazing, oh, and it was driven by a mouse. Does that all sound familiar? Okay, so there was a mouse, and you used the mouse as the pointer, and all the strategies for cutting and pasting and all of that stuff and this graphical user interface all existed in 1978. So, what happened? Well, in Xerox, in 1978, made an attempt to commercialize the Alto. So they developed a whole division, they staffed it, and in 1981 they introduced the Star Workstation and distributed computing system. Unfortunately, the machines were about $15,000 a piece and too expensive for most corporations, and the other fatal flaw that they made is because all of the technology that had been developed at PARC was closed. It didn't use standard operating systems, it didn't use standard hardware, it didn't use standard anything. It used a standard, it used even its own programming language, which was called Mesa at that time. A lot of us that were in the research community said, this is not going to work. So in 1979, Bob Metcalf left to form 3Com, which obviously sold the Ethernet. Now, the other fatal mistake that Xerox made is they gave a tour to Steve Jobs. He came in and he looked up and down, and at that time they were still Apple II people. Okay, and he had never seen anything like this, and so he wandered around, looked at everything, looked at the graphical user interface, looked at the mouse, and left. He then immediately hired Larry Tesler from PARC and Bob Belleville, who were engineers. Bob Belleville was out of SDC, and he built the Lisa computer, which was the first graphical user interface personal computer with a mouse, and he sort of got it wrong the first time. and it wasn't very practical. So also at that time, in 1981, Charles Simone joins Microsoft, and he actually developed Word and Excel for Microsoft. Charles Simone is also one of the smartest guys in the world. Chuck and I said, you know, this is not going to go anywhere, so we decided to leave Xerox in 1982, and we were bound and determined to figure out how to make laser printers broadly available. It's interesting, after we started in 1982, we started in December, and that March, I got a phone call, and the guy on the other end said, well, hey, this is Steve Jobs. Bob Belleville tells me you guys are doing great things. Can I come over and see? And he did, and we showed him PostScript, and he got it immediately. I mean, he figured out that the image writer on the Macintosh was not going to fly, that the a wire matrix printer was not going to fly. So we started discussions, and after about a month or so, he said, gee, why don't you let me buy you? And we said, no, we've just started on our own, and we haven't had any time to see how this is going to work. And so he offered to buy us for $5 million, and we declined. Instead, he invested $250,000 into the company and gave us $250,000 as an advance on royalties to build the laser writer. So we built the laser writer. In 1984, the Apple Macintosh was announced. In 1985, Microsoft, which is the great leader that it is, said, we have to announce Windows. So all of the graphical user interface ideas actually came out of PARC. They weren't invented elsewhere. They were all invented at PARC. In 1985, we announced the Apple Laser Writer, and we concurrently announced the Linotronic 100, which gave you super high resolution, typesetter-like output, and gave you the desktop laser printer. In 1985, Steve Jobs was fired from Apple, but they picked up the desktop publishing bandwagon, and that carried Apple through for a number of years until Steve came back. So the personal computer is all today that we have today is all about graphics, and most of the graphics was actually invented here and transported to Xerox, developed into Xerox, and so it's been a great ride. Adobe, we started with PostScript, and we felt that we had to have an application, and so my wife was a graphic artist, and so we figured out how to build Illustrator, and a gentleman named Mike Schuster programmed Illustrator, and people didn't know what it was when it was first announced. In 1989, we had the Knowles brothers come down and show us on a 512K Macintosh. Now imagine this, folks. On a 512K Macintosh, black and white, they demoed Photoshop. Okay, the biggest hard drive you could buy then was 20 megabytes. Now think about the storage you guys use today, and compare 20 megabytes to anything. And it is a world, and we said, you know, the world is going to change. Technology is going to go forward. Machines are going to get faster. Memory is going to get cheaper. I never imagined memory would get as cheap as it is today, but memory is going to get cheaper, but we should buy Photoshop. So we bought Photoshop and settled into the niche of printing, publishing, and all 2D creative stuff. If you think about it, the Xerox group was sort of the world's best collaborative group, because it came from all over the country, from different cultures, from different attitudes, different specialities, hardware guys, software guys, network guys. And it was that hybrid vigor between the people who worked at PARC that made it really successful. It was an amazing place. what you've got here is great collaboration between the various departments, and this whole program has been about collaboration. I strongly believe that the way you get hybrid vigor and the way you get real problems solved is get people in diverse fields with different attitudes about things together in a room and say, what can we do together? Thank you. Oh, one last thing. There's the other half of the ARPA story. So in 1968, the date that's through there, I went to a conference for ARPA of the general scientists at Alta, Utah, at the Rustler Lodge, and they discussed building the internet, the ARPANET at that time. But they said, because we have all of these different centers of excellence, we have to get them to communicate with one another. Now, the first version of the internet was at the awesome speed of 56 KB in terms of bandwidth. So they were not wide pipes at that time. But that then became the internet. And I don't think the world would be the same. So you need to thank ARPA for the internet. Anyway, thank you.
Can you entertain a few questions?
Sure. Questions? Yes.
I think an interesting part of your story is how Ivan and then later Bob Taylor both came through Utah as academics.
Yes, they did.
And I'm wondering, what do you think there was that sort of inspired those moves? Because they were sort of key in the story, I think.
Well, Ivan didn't ski very well, so I couldn't have been skiing for Ivan. Actually, Dave Evans was a very inspirational boss. People would create. I mean, he was just, he wouldn't tell people they couldn't do things. He would tell them how they could do things. And he would allow them to really take wild shots. And I think they both had tremendous respect for what was being done at Utah.
Questions? Yes.
Yes.
In addition to what was going on in Xerox PARC during the 70s, were there other international efforts going on that were sort of competitive? Obviously, the Xerox PARC, what you were doing was the bleeding edge, but were there other international things going on at the time, or were you guys just 3 steps ahead of the game?
I actually think we were about 3 steps ahead of the game. Nobody knows this story because Xerox was incredibly secretive. They did LSI designs for chips. They were incredibly secretive. Until I interviewed for a job, I had never known what was going on at PARC, and no one ever told me what was going on at PARC. I think it was, I'm trying to think of who the director of PARC was that said, oh, it won't hurt to let Steve Jobs see what we're doing. But it was sort of a pivotal moment because, and you know, there was a huge disparity between the management of Xerox and PARC. PARC did all of this incredible inventing, and the management of Xerox were essentially ex-Xerox salesmen. And they really had no clue or no vision of what this could do to the world. And so there was a real mismatch and a real problem in getting the research out of Xerox into the corporation. And there are multiple books written about this subject. Yes?
But can you comment on any role that Bell Labs had in all of this development?
There were all kinds, yeah, MIT and Harvard, most of the graphics that was done at that time was vector graphics. In other words, you could build a display where you could take a cathode ray tube and drive the magnetic drivers and draw lines on it. So the picture of me sitting in front of one of those cathode ray tubes was a vector machine. And so all the work was about vector machines. No one had done any work on raster machines because no one could drive them. And so there really was very, very little work going into that area, and that's where Dave saw the future, and that's where he took that research. But there was a lot of work in hidden line work by Larry Roberts and others at Bell Labs and to solve the vector problem. And Ivan actually, when he was 23, did Sketchpad, which was the first interactive graphics program, but it was on a vector machine.
Great talking. What's your vision of computing and personal computing 30 years from now?
Oh God, who knows? Jeez. Yeah, right. Maybe, how about tomorrow? What's happening? It's the things that you can predict, though, that you can see happening, is the whole culture is changing because of online and smaller devices and faster bandwidth. And I mean, who would have imagined 20 years ago you could go to your computer and ask any question in the world and almost have the full body of knowledge about any subject available at your fingertips? I mean, the internet is an amazing tool. And so technology is accelerating. So I would never let your vision be impaired by the fact that your computer's not fast enough or you don't have big enough memories or something like that, or that you can't solve the problem today. Forget about that. Solve the problem, get it working, and technology will take care of itself.
Yeah, the intellectual properties in 1968, the intellectual property law, help you, hinder you, or were irrelevant?
Well, this is the second part of the funny story. So when I went to Xerox PARC, I had been at Evans and Sutherland, okay, and we were building big simulators, and our little office had the problem of building the databases for these simulators. In other words, we did a simulator of New York Harbor, and we had to build a model, essentially a digital model of New York Harbor with the buildings and everything. So we developed a programming language that we called the design system, and that I implemented at Xerox and called it JAM, which stood for John and Martin. Martin Newell and I did it together. And then when we went to form Adobe, we called it PostScript. Okay, same language for building New York Harbor, doing all the work, exploratory work we did at Xerox. Well, when we left Xerox, they said, no, you can't do that. So I went to Dave Evans and I said, you know, we use the design system. I should actually license the design system from you. So we gave him a whole bunch of stock in Adobe for use of the design system. And so when we met with Xerox lawyers, we explained this situation and their faces turned white because they had been using what they felt was their technology and it was somebody else's. So we were off scot-free. Yes?
I work in a field where prices are dropping even faster than they have in the computer industry. Our possibilities are expanding also faster. That is personalized genomics. And we are coming from human genomics to now really personalized genetic medicine. What would you advise us to envision where we might be 5 years from now?
What, in genetics or?
Yes, and how to envision a process that is so rapidly changing that we have a hard time to even envision what our medical culture might be like in 5 years. Now looking back at your experience, what would you tell us to do? Well,
I think we should stop global warming, number one, or else it's not going to be around for anybody. But, you know, it's remarkable how fast things are moving. I mean, it's just absolutely mind-blowing what problems are being solved in genetics. And the thing is, I think from the medicine's point of view, you should ask as hard a questions as you can of the engineers. Say, how do I solve this problem? And pass it over to these guys and say, here's my data. How do I deal with this data? And how do I make this data most useful to me as a scientist? And don't worry about what their computing capacity is or how hard the problem is. These are smart guys, they'll figure it out.
I find it interesting that you Utah helped develop some of the technology, but a lot of the commercialization all happened in California. As you think about how we improve our ability to commercialize here, what advice would you give to everybody here in the room?
Well, actually about, I don't know how many years ago it was, I sat down with Governor Leavitt and I said, here's the deal. I said, Silicon Valley is built for startups. It has lawyers that understand startups. It has venture capitalists that understand startups. It has banks that understand startups. It has people who lease space who understand startups. So all of the tools that you know, human resources all of the resources are there. So if you want to start a company, you have 15 choices of how to get funding and make a startup. And I said, you know, in Utah, you should do something, you should make it a healthy economy to do that. And the U-Star project actually came from Governor Leavitt. And so I think he actually listened, and he came back and he did something about it. So I give him actually a lot of credit for doing things. But that you have to understand, the society there is when you go to a party, half the people of the party are in a company that's teeny. It's a startup mentality. It's an entrepreneurial, capitalistic mentality for starting companies, and you just have to be prepared to live in that kind of environment.
One more question? Yeah.
So it's like to continue the question about 30 years in the future, as technology is getting more advanced and our internal hardware stays the same for thousands of years, do you think like proprietary software will still be competitive in 30 years, or people will have to move more like into the modern science way, with the shoulders of the giants, to be able to handle this ever advancing, more complicated technology?
Well, the technology is vastly complicated. Programs are horrendously complicated, but the tools for dealing with massive complexity. I mean, if you look inside of Photoshop, for instance, or any of the large InDesign programs or Acrobat, these are huge, huge pieces of code. And they have to be managed across multiple implementations and configurations, and they have to be tested. And it is a massive engineering infrastructure just to support the programming. And, you know, hopefully there are a lot of computer scientists who pay attention to that problem. One of the decisions that we made is that all of our programs were going to run across all of the platforms. And so early in the early years of Adobe, before there were a lot of platforms, we started putting infrastructure into place to stay independent of the operating systems, to have very clean interfaces between the operating system interfaces so that we could port programs and have core technology that we wouldn't have to re-implement over and over. And we've tried to take that technology onto the phones. Do you know that there are in the last 3 months, about 150 new phones? And if you're trying to build applications across all of the Android phones and, I mean, all of this plethora of tablets and devices, you can't do that on a device-by-device basis. You have to build an infrastructure where you can leverage the program development across all the devices. I hope that helps.